representation or a table is said to be in Boyce Codd Normal Form, in short BCNF, if it is already in third normal form and for any dependency A determining B, the determinant A must be a candidate key, which means A cannot be a non-key attribute with B being a key attribute. Consider this table student. This table is in second normal form because the attribute faculty depends on the composite primary key through full functional dependency, which is student ID and subject taken together. This table is also in third normal form as there is no transitive dependency where a non-key attribute determines another non-key attribute. This is because the columns student ID and subject taken together forms a key attribute which determines the non-key attribute faculty. But even though these tables are in second normal form and third normal form, it is not in Boyce Codd Normal Form. In the next slide, I will show it with an example. In the above table, a particular student can opt for multiple subjects, so student ID will have duplicate entries. This is shown by the column student ID with a value S10 opting for two different subjects, which are computer and IP. In the same way, a particular subject can be taught by multiple faculties, which brings duplicate entries in the column subject. This is shown by the column subject with the entry computer representing two faculties, which are Mr. John and Mr. Sen. As a result, both the attributes student ID and subject has duplicate entries. The attribute student ID has duplicate entries of S10 and the attribute subject has duplicate entries of computer. That's why the attributes student ID or subject taken alone cannot become the primary key in the table student. So both the attributes student ID and subject are taken together and then they form a composite primary key or a candidate key that can uniquely determine every row in the table student. The unique entries of the composite primary key are S10 computer, S10 IP, S20 maths, S30 English, S40 chemistry and S50 computer. Clearly, there are no duplicates, and that's why they are unique. So the composite key student ID and subject taken together forms a key attribute which determines the non-key attribute faculty. This can be seen by the first representation pointed to by arrow in this slide. Since this representation shows a key attribute determining a non-key attribute, this is acceptable. But there is a problem. The problem is that this table is not in Boyce Codd Normal Form. Let me explain you why. Just look at the table student. See the column faculty. All its entries are distinct. You will also notice that two different faculties, Mr. John and Mr. Sen, are teaching the same subject, computer. This shows multiple faculties can be assigned to a particular subject. As a result, now the non-key attribute faculty determines the key attribute subject, which is the part of the composite key. And the composite key is student ID and subject taken together. This is shown by the second representation as pointed to by arrows. Since this representation shows a non-key attribute determining a key attribute, this is not acceptable as it gives rise to anomalies. Now I will explain you about the anomalies which occur when the non-key attribute faculty determines the key attribute subject. Let's start with the insert anomaly. Now consider the above table student. Suppose a new faculty has joined the school and no subject has been assigned to him yet. In that case, the entries of the composite primary key attributes student ID and subject will be null for that particular faculty who has recently joined. As primary key column does not allow null values, so we cannot insert that record. And this is the case of an insert anomaly. Now let's discuss about the delete anomaly. Consider the above table student. Suppose the student having student ID as S20 takes a TC and leaves the school for some reason. In that case, the entire record with student ID as S20 have to be deleted. But another thing to be noted is that if you see the table, the faculty named Mr. Kumar has been entitled to only this particular student with student ID as S20. As a result, after deleting this student's record, the faculty information also gets deleted. So this is the case of a delete anomaly. The solution to overcome these anomalies is to split the table student into two different tables. Those are student 2 and faculty as shown in this slide, so that no non-key attribute determines a key attribute. The student 2 table comprises of the attributes student ID and faculty, where student ID and faculty taken together is the composite primary key. The faculty table comprises of the attributes faculty and subject, where faculty is the primary key. Now, if you look at the table student 2, even if the student with student ID as S20 takes a TC and his record gets deleted, the corresponding faculty information associated with this particular student is not lost. This is because even if the faculty Mr. Kumar associated with the student with student ID as S20 gets deleted from the student table, it does not get deleted from the faculty table, as Mr. Kumar still exists in the faculty table. Again, if we wish to insert a new faculty who has recently joined the school and no subject has been assigned yet, we can do so by simply filling up the faculty entry in the faculty table with the associated subject as null. As subject is not the primary key or a key attribute in the table named faculty, so it can accept null values. Finally, after the table student gets splitted into two different tables, student 2 and faculty, no non-key attribute determines a key attribute in those two tables, and the anomalies are eliminated. As a result, these two splitted tables, student 2 and faculty, are in Boyce Codd Normal Form, in short BCNF. Now look at the two tables, student and faculty. In the table student, the attribute faculty was a non-key attribute, whereas the attribute subject being a part of the composite key, which is student ID and subject taken together, is the key attribute. The non-key attribute faculty determines the key attribute subject. But once the table student gets splitted into two different tables, which are student 2 and faculty, the attribute faculty becomes the primary key in the table faculty. That is why the attribute faculty becomes the key attribute, and it then determines the non-key attribute subject in the table faculty. As a result, the attribute faculty, which was once a non-key attribute in the table student, has now become a key attribute in the table faculty, and then it determines the non-key attribute subject in the table faculty. This clearly shows that non-key attributes determining key attributes have been eliminated, and now only key attributes are determining the non-key attributes. Hence, this shows that the splitted tables student 2 and faculty are in Boyce Codd normal form.